The acceleration of a particle is defined by the relation a is equal to 3e to the power minus 0.2 t, where a and t are expressed in feet per second square and seconds respectively. Knowing that x is equal to 0 and v is equal to 0 at t is equal to 0, determine the velocity and position of the particle when t is equal to 0.5 seconds. So we are given acceleration a is equal to, as a function of time, 3 into e to the power minus 0.2 t, that is a as a function of time. And we are also given x is equal to 0 when t is equal to 0 and v is equal to 0 when t is equal to 0. Now we have to find the velocity and position when t is equal to 0.5 seconds. So let us first obtain expressions for velocity. So we know the relation between velocity and acceleration and time as a is equal to dv by dt. Since a is given as a function of time and we have to find v, I am using a relation between a, v and t, which is 3 into e to the power minus 0.2 t. So rewriting this, we get dv is equal to 3 times e to the power minus 0.2 t dt. So integrating between our limits v0 to v dv and t0 to t, 3 times e to the power minus 0.2 t dt, we get v minus v0 equals 3 divided minus 0.2 e to the power minus 0.2 t from t0 to t. So v0 is 0, so v equals, and t0 here is also 0, so this term becomes 15 minus 15 into e raised to minus 0.2 t, and on substituting t is equal to 0 we get minus 1. This also I can write it as 15 into 1 minus e raised to 0.2 t, right? So this is our expression for velocity. Fine. So now let us obtain an expression for acceleration, distance. So I know the initial distance at time t is equal to 0. So we know the relation between velocity and distance time is v is equal to dx by dt, which is 15 into 1 minus e to the power minus 0.2 t. So rewriting, dx is equal to 15 into 1 minus e to the power minus 0.2 t dt. So integrate in the limits x0 to x dx, and same here 15, integrate between the limits 0 to t, t0 to t, where t0 is 0, 1 minus e to the power minus 0.2 t dt. So our terms, this term becomes x minus x naught, it is at time t is equal to 0, x naught is 0, so this becomes 0 equals 15 into 15 into t minus e to the power minus 0.2 t divided by minus 0.2 from 0 to t. So this particular equation I can also write it as, so let me rewrite this. So here x is equal to 15t from 0 to t and minus 15 e to the power minus 0.2 t divided by minus 0.2 from 0 to t. So this becomes 15t minus of 15 into, so this value here, that is, this is minus 5 and e raised to minus 0.2 t minus of into minus 5, again minus 5. So this gives me 15t plus 75 into e raised to minus 0.2 t, and this 15 into 15 multiplied, this gives me minus 75. So this is the expression for x. I can also rewrite it as x is equal to 15 times t plus 5 into e raised to minus 0.2 t to minus 75. So these are our expression for velocity and distance. So let me rewrite again the expression for velocity as v is equal to 15 to 1 minus e to the power minus 0.2 t. So now we have to find at time t is equal to 0.5 seconds the position and velocity. So we will start with velocity. So the velocity v equals 15 into 1 minus e to the power minus 0.2 t at t is equal to 0.5, 15 into 1 minus e to the power minus 0.2 into 0.5. So on evaluating we get v is equal to 1.427 feet per second. Now the distance we have, x is equal to 15 into t plus 5 times e to the power minus 0.2 t minus 75. So on substituting t equals 0.5, this here is 15 into 0.5 plus 5 into e to the power minus 0.2 into 0.5 minus 75. So this relation on evaluating will give me 15 into 0.5 plus 5 into to the power minus, I'm just substituting the values in calculator. So this gives the value as 0.3628, that is minus. Fine, so this is our position x at time t is equal to 0.5 seconds. So these are our answers. Thank you.